One lovely summer morning, Sam woke up with a wonderful question.
What if the amount of candy I eat affects how well I can catch a ball?
She must find an answer to this question and will not rest until she does. But does she have enough statistical knowledge to stand the test? Now, you can't just get started all willy-nilly with an experiment.
I can't?
No. First, you need to know the basics of an experiment. Let's start with a little bit about variables.
Variables?
Variables. There are explanatory and response variables. Explanatory variables may help explain or influence changes in a response variable. You need to be careful of lurking variables and confounding as well. A lurking variable is a variable that is not among the explanatory or response variables in a study, but may influence the response variable. Confounding occurs when two variables are associated in such a way that their effects on a response variable cannot be distinguished from each other. So before you begin testing, tell me, what are your explanatory and response variables?
Well, the explanatory variable must be the amount of candy they eat. And the response variable must be how many times out of 10 they catch the ball. And the lurking variable is probably the sex of the subjects, because I guess candy could affect males and females in different ways. I don't think confounding would occur.
Correct! Now that the variables are established, we must identify the type of design for your experiment.
Ooh, I think I know this one. So we would use a block design because candy could have a different effect on the male and female bodies. And also, one sex could be better at catching the ball than the other. So by blocking by sexes, we avoid any variation and the lurking variable.
But you forgot something!
What did I forget? The control group, duh.
The control group is the experimental group that does not receive any treatment.
Ooh, so we would have a control group that doesn't eat any candy.
You could separate the people within each sex into two groups. One group will catch the ball without eating any candy, and the second group will catch the ball already having eaten candy. Gosh, like it's hard.
That sounds perfect! Now that we have established this, we need to design the experiment using the principles of random assignment. In statistics, random assignment is one of the most important principles, as it assures that any significance in the results is unbiased, assuming the sample was randomly selected. How do you suggest that we go about performing random assignment?
Okay. So why don't we put the candy in alphabetical order, right? Okay, I get this. And then we put the subjects in alphabetical order, and we run the experiment.
Come on, Sam, that's like not even random.
Ow!
Random means that the candy is selected without method or conscious decision.
Oh, okay. So we could divide the group by sexes, and then within each group have them pick numbers out of a hat. So the numbers would either be 1 or 2, and there would be an equal chance of picking either a 1 or a 2. If they pick a 1, then they don't eat the candy. And if they pick a 2, then they do eat the candy.
That is a great idea!
Yay!
Keep in mind that this is a great time to use single blind or double blind.
Wait, so I can't see?
Double blind is when neither the subjects nor those who interact with them to measure the response variable know which treatment a subject received. And single blind is when the individuals who are interacting with the subject and measuring the response variable don't know who is being treated and who is not.
Oh, so you will use single blind so that one subject doesn't know that the other one has eaten the candy.
Now that we have all the principles of experimental design covered, we are ready to conduct our experiment. Remember, the format for this experiment is called a block design. A block is a group of experimental units that are known before the experiment to be similar in some way that is expected to affect the response to the treatment. A block is a form of control. In a randomized block design, the random assignment of experimental units to treatments is carried out separately within each block.
Oh my god, that was so much fun!
You would find that fun, dork.
Well, that question is solved, but wait, another idea!
What is the effect of shoes on kicking effectiveness?
Not again.
How will you test this one?
Why do I always get dragged into these things?
So, I'm not really sure how to set up this experiment. Maybe I should just use a block design.
Not quite. See, we need to reduce confounding as much as possible. So really, you should use a matched pairs design.
What's that?
You really are clueless, aren't you?
Oh, hush up. In a matched pairs design, we create matching pairs of similar experimental units. Within each pair, the units are assigned to either of the two treatments. We then compare the results within each pair.
Ooh, so in my experiment, each person would wear 2 different types of shoes. That way, the same person would be kicking within each pair. That would reduce confounding, right?
Wow, you're so smart. Gold star for you. Good riddance. Let's just get on with the experiment already.
But wait, what's our treatment?
Well, a treatment is formed by combining a specific value or level of each of the factors. In this case, your factor is shoes. Levels are the options of the factor. That would be the type of shoe you use.
I could have told you that.
That's enough out of you, Ramona. Let's get to it, Sam.
Wait! Did you forget random assignment?
What are you talking about, Ramona? I thought I had this one in the bag.
You dork. You must randomly assign the shoe type to either the left or right foot. What if people are left foot dominant or right foot dominant?
Your friend is right, Sam. You need to randomly assign either shoe type within the pairs. Otherwise, everyone could put a sneaker on their dominant foot, and our results would be flawed.
Oh gosh.
Hey, Sam?
Yeah, what's wrong?
How do you expect to measure the response variable? You know, kicking power?
Oh, well, we could just ask how much the kick hurt. Like this. Hey, soccer ball. How much did that hurt? On a scale of 1 to 10. You okay? You don't want to talk? It's okay. I won't judge you. This is the judgment-free zone like Planet Fitness. Why would he speak to me?
Can you think of another way to measure the effectiveness?
I mean, I guess we could measure the distance that the ball travels. He's not being very cooperative today. Let's do this. Five. Yeah, we did it! The soccer ball never did talk to me, though. It's okay, buddy.
You know it's never going to talk to you, right?
It can hear you! It has feelings! Way to kill the moment, Ramona.
I'm just so done with this experiment stuff. Can we just get ice cream and binge watch Supernatural?
On a scale of 1 to Kaufman, how done are you?
That's some reference I didn't get.
I just had another idea for an experiment.
Alright, Sam. Just this last one, I suppose. What's your idea?
What if we surveyed all the statistics classes and asked them how done they were with stats on a scale of 1 to 10? And then we compared it to Ramona's level of doneness.
I guess you could do that. I don't know how significant that is.
Significant? What do you mean? This experiment is important to me, narrator.
There. Why do you have to be so insensitive?
I think you two may have misunderstood. In statistics, significance doesn't refer to the importance in that sense. When something is statistically significant, it means the results obtained are not due to chance. That means, in a well-designed experiment, the results are due to the explanatory variable.
Well, what if I surveyed all the stats classes in America?
Sam, how are you even going to do that? America is huge. Like, bigger than Australia huge.
How about something smaller, like all the stat classes at your school?
Well, that sounds reasonable. But how would I design that? The classes are majority upperclassmen, so I don't think I would need to block anything.
Why not a completely randomized design, my junior statistician?
A randomized design? What's that? It sounds really disorganized.
Not at all. A random design is when the treatments are assigned to all the experimental units completely by chance.
Oh, so we would randomly assign subjects to either complete a hefty review packet or not do the packet. And then we would ask them how done they are with stats.
Which is probably, I want to go home right now kind of done.
Awesome! Make sure that you set a time for them to work on the packet or sit in the room and do nothing. Say, half an hour?
Gosh, that's just cruel.
Cruelty is necessary for statistics, Ramona.
Alright, let's do it then.
Wait!
What?
You can't begin yet! We gotta define one more term before we can start. Do you know who your experimental subjects are?
Well, the experimental subjects are the smallest collection of individuals to which treatments are applied. And my subject would be the group of students completing the hefty review packet and the group of students not doing the packet.
That's right! Now you can start.
Alright, we gave the students the packet for 30 minutes and then we gave them the survey. And here's what they said.
On a scale of 1 to 10, how done are you with stats?
Please leave. Like, you can go. 0. I could never stop loving stats. It's my favorite class. I don't want to leave it. I hate all of the classes.
And the students who didn't get the packet.
On a scale of 1 to 10, how done are you with stats?
So done, my soul has left my body.
10. Just get me out. Get me out now. Please, get me out now. 10.
I guess that we can conclude that everyone here is done with stats.
About as done as we are with this video. JK, we're not done quite yet.
It appears that Sam and Ramona have run out of ideas for stats tests. I think that's a blessing for everyone.
Hey!
We hope you all had fun with our statistically significant schemes.
Remember, next time you're conducting an experiment, you must follow all of the statistics concepts covered in this video.
And have a sassy friend to help you along.
Bye!
What if the amount of candy I eat affects how well I can catch a ball?
That was so bad. No, don't look
What if the amount of candy I eat affects how well I can catch a ball?
Now keep walking.
Significant? What do you mean? This is a very... You can't hug me while I'm
You did it too early. You did it too early.
When do I hug her? Foot dominant or right foot dominant? Don't you think you should randomly assign the shoe type to the foot
God damn it. That was so
To the
good.
type of wait, the soccer ball never did.
Never did.
Never.
Station.
What? Goddamn car.
Screw you, car. Not too close. Too close. Too close.
Too close for comfort. I can't. Can you see me?
Sorry. No, you talk. It's fine. Wait.
I don't know if the camera can see me.
Talking to Garrett is so important.
Can the camera see me?
Ooh.
Oh.
Yeah, the camera can't see you and it's recording.
Ah!